is just to get some reproducible data, and we'll look at, say, the cuvette and the 96 well plate shown here. So this is just clear bottom, flat, round well. And depending on which one you use, you're going to have some different errors associated with it. So we'll start with the cuvette. The one I like is the quartz cuvette. The nice thing with this is that you can get different path. Basically, the path length is fixed, but you can actually get it reduced volume. So in this case, this would be probably less than a mil of liquid. And the nice thing with this one is that when the light comes through, you at least have a fixed path length, so that's always going to be consistent. So that reduces the amount of error that you're going to have when you do these readings. Now, some of the drawbacks might be is that because it's glass cuvette, quartz cuvette, you might have a little bit of bending of the light, so it actually will not travel 180 degrees. It may bend a little bit, and not all of it will hit the detector. So that's the quartz cuvette. Now, this one here, the 96 well plate, the challenge you're going to have with this is that the path length will always be different based on your pipetting. So if we look over here at this diagram, here I show the cuvette and microwell plate. Again, as I said before, this is a fixed path length because the light's going this way, but the problem with the microwell plate is that we'll have either a meniscus, depending on the solvent we're using, and second, this will be variable. If you have some pipetting error, the path length will always change, and that's going to be a problem getting reproducible data. So what I recommend is you try to fill up these wells to the highest volume. Typically these would be around 280 microliters to about 300 microliters. You'll have to see when you pipette, and just make sure that there's no bulge on the top. And the last thing is that when you want to take the reading, you want to take the light from the bottom, a bottom read, and this will minimize the light scattering if you do it from the bottom. If you go from the top, the problem is that the light could hit the edge of the meniscus and the light will scatter. So that's where you're going to get the highest error, so therefore always take the reads from the bottom. Another useful thing is that when you pick your plates, there's different types out there, and just make sure that the plastic you pick isn't absorbing the wavelength that you're interested in reading. And sometimes these do have a natural tendency to absorb specific wavelengths, so always check the specifications before using them or doing your experiment. So if you're doing fluorescence, this would be black, and that's to prevent any autofluorescence coming from the plastic. If you're just using regular vis, this would be a clear plate. If you're doing luminescence, this would be a white plate. And then there's some other small variations of how the bottom looks like. It could be clear bottom or opaque.
Okay.
So those are all the tips I have for today.